What's going on, everybody? Welcome to another episode of Iron Culture presented by Mass. I am back with my comrade in arms, Dr. Eric Trexler. How you doing tonight, man?
I am doing great. How are you?
I can't complain. We've got a great guest on. We are joined by Dr. James Steele, who is working very hard to be one of the most hated people in sports science.
It's working on me. I can't stand this guy.
Yeah, we had to have a pretty strong back and forth debate to even allow this episode to happen. So I do appreciate the time you've spent studying Buddhism and becoming at peace with things, because I think there's a prior version of Eric where this episode just wouldn't have happened. So
I've grown up a lot, and I've also realized that you can't conquer your foes unless you face them head on. So this is me trying to destroy James and his career.
Spoken like a true Buddhist. I love it. No, that's great. And before we actually let James speak on his own behalf, because that's not a thing we do here at Iron Culture very much, at least not in the first 10 minutes of banter. Let's just say, hey, we hope you folks have been enjoying some of these pre-recorded episodes with the guests we've been having. We're trying to mix it up and also bring some of the live episodes where we engage with our audience. We are absolutely going to be getting back to that, but we want to make sure that we're also getting these deep dives on the specific topics and leveraging the expertise of the folks we have in the field. So if you've been enjoying that, please do help us out here. You can give us a subscription, you can give us a follow, you can give us a thumbs up, you can give us a 5 stars. Whatever platform you're on, we greatly appreciate it. That's what this show thrives on. And of course, if you really do want to support Iron Culture presented by Mass, then supporting Mass would be of great help. We're actually going to reference some of the work that we've done in Mass in a specific conversation. But yeah, if you want to join myself, Dr. Trexler, Dr. Lauren Colenso-Semple, and Dr. Zerdos as we put out monthly content, we would love to have you. And if not, that is all good. Just keep joining us on the podcast. Keep helping us out. And finally, I'll say, hey, we're only weeks away from the 4 of us being in Austin, Texas for the annual Sports Nutrition Association conference, where each of us, the whole Mass crew, is going to be presenting live. So if you want to meet us, get some time, just grab a cup of coffee between presentations, or heckle us from the back of the room. We highly encourage that, so definitely check that out. We'd love to see you in person.
Yeah, and last time I was in Austin, Texas, I got a little too rowdy over on 6th Street, so that could happen. You never know. And another thing about Austin is, have you heard of the bats, Helms?
I have not only heard of them, I've seen them.
Yeah, so you got to go. If you don't care about fitness, that's fine. Frankly, no one does. Certainly James doesn't. But bats are cool, and there's this bridge where right when sundown hits, like 1 million bats fly out all at the same time. People gather around to watch. It's really, really cool. So if not for the fitness, come for the bats.
Yes, absolutely. I can echo that. When I was there with my wife, who is a huge animal lover and animal expert, she was enthralled with the bats, and it's pretty cool. She's like, "Oh, that's a big flock of those aren't birds." Oh, wow.
Yeah.
Although,
little warning in the interest of our virology buffs out there: do not interact with these bats.
Yes, do not
let
feed
them
the
go
bats.
Do their thing.
Don't try to get them to land on you. Nope. This is how pandemics start, according to conspiracy theorists. So,
yeah,
which, as of course, we endorse the right conspiracies here on Iron Culture. Well, with all that said, and now that people know that they can both get nutrition information as well as a bat experience, that they should maybe keep a visual experience rather than a tactile one, Trex, maybe we should let our guests speak. So, Dr. James Steele, welcome. Thank you for joining us. And how are you doing?
I'm good. Eric's squared. I'm very good. Thank you for having me on. Actually, this is the second time I've been on. I was on way back when with you and Omar, I think. We did a session on open science. So,
yep.
It's good to be back. I've listened to some of the shows lately because rumors and whispers have been going around that you guys keep on mentioning my name, and I thought, let's stop this kind of like coyness, and why don't we actually get on a call together and we can flirt in person.
that's what we wanted, instead of having people pass you notes, just to come and talk to us, So we've moved from middle school to potentially high school level of personal interaction now. So no, really appreciate you having you on. And for those who don't know, yes, Dr. Steele has been on before, talk about open science, and in the Iron Culture documentary that is currently being edited, he also has a really big role there as I visited Solent University, which was a ton of fun. So I think to give people a little bit of backstory as to why I was facetiously saying that you're trying to be hated by the exercise science community, I think you do, in my opinion, a very good job of bringing up very relevant critiques, and not on a kind of small scale, not on things like, hey, you probably should have done a different statistical analysis, let me just write a letter to the editor, but kind of big picture, like, there's some ways that we are doing things as a field that are out of step with modern scientific philosophy. And I think that's pretty understandable when you have a field that was not started within science. It very much emerged out of practice, and it is very much an applied field. We see similar things in psychology and sociology and as it's advancing. And while it may be a bit of a painful process to examine some of our own issues, especially for people who feel like that has maybe come at the expense of the way their work is perceived, ultimately, I think you're doing good work. So one of the shots across the bow of the roots of sports science that I want to call out to is actually a textbook chapter, which is, I don't think it's fully gone to press yet, but you authored it.
It has actually.
Oh, has it?
The copy is just above my head on the shelf.
Oh, okay. So it is.
Yeah.
It is fully out. Okay, so people can. So you are now influencing the youth. You have harmed the next generation of sports scientists. You've turned them against tradition. But no, in all seriousness, you wrote I would say a provocatively titled book chapter called "The Myth of Periodization." And
I wonder what it's about.
Yeah, it's about myths. But actually, I think the framing of myth is quite interesting because it perhaps is not what the typical person in the evidence-based space would think. Because when they think of myth, they think of like myth busting. And I think you did a good job. Again, it is quite provocative of framing. Hey, what is the difference between a myth, and more importantly, what do we really want? What is a theory? Because people have framed periodization as a theory. And to give a little bit of background context before I kick it over to you, I would say that, we've talked about the emergence of exercise science, which very much came out of medical science. And there's some pretty cool history there. But I would say the history of quote unquote sports science almost paralleled the development of our modern conception, at least, of periodization. Now, granted, long-term training planning has existed for thousands of years, don't get me wrong, and you can find historical, texts dating back to that across every culture that, had physical activity. But the Matveyev kind of, Western or linear periodization that came out of, his work is sort of the inception and the birth of quote unquote sports science. And it was very much, inductive versus deductive, right? It began with, here's what a bunch of athletes are doing, seems to work, let's talk about this, and then try to figure out why that happened. And you can see the echoes of that mentality in what we do. And I think that's pretty normal when you think of a practitioner-led developed science. And that maybe is not the way that it should end up, even if it's quite normal for things to start that way. So I would love to get it kind of from the horse's mouth, because I know that there were some ruffled feathers in response to that. In Mass, I wrote specifically about the quote-unquote periodization war, which was your book chapter and the various publications since, I'd say probably John Kiley was the first one to kind of put his hand up and go, some of this stuff around periodization doesn't make sense to me, back in 2012. So it's been more than a decade of people pointing out some of the issues, at least with the way periodization is represented, if I want to give the most charitable take. And the most recent kind of chapter in that back and forth is not only your book chapter, but also the critique of it, titled "The Myth of the Myth, an Opinion by Stone et al." So this is a battle between Steele and Stone, which you can't make this stuff up. These are real last names. in this area.
Hard place.
Exactly, quite literally.
Wait,
Yeah.
maybe that's why he misspelled my name in the first instance in the paper, so he could actually spell it as Steele without the E.
Yeah, he's trying to steel man you, you know? So,
there we go. I completely
so
missed that.
yeah, man, you got to give the old man some credit. You know, he's been in the game a long time. He knows what he's doing. So, for those who don't know, Mike Stone is easily the most prolific academic in the space of studying periodization, at least in the U.S. He's been doing his thing at ETSU for a long time, and Trex and I actually got to meet him when we presented out in Finland in 2018 at a conference, and it was pretty cool. We got to sit down and have a meal with him and talk to, like, literally before Trex and I were born, how exercise science and sports science was conducted. So I do want to be clear, like, all respect where respect is due. We do stand on the former work of others.
And I should mention, this man is about the iron. Like,
yes.
he is absolutely, you can't fake it. This man is all about it. So you got to give a tip of the hat to anyone who's been not just in the broader culture of iron, but when you put a good, like, 6 or 7 decades into it, like, that commands respect.
Oh, we trained together. Yeah, there wasn't just that. He was out there squatting with Kyle, is the PhD student he was with, who's also doing a lot of good work. He might have finished his PhD now, but anyway, nonetheless, ate with the man, talked science with the man, watched him do some low bar squats. He's definitely hitting depth. It's no joke. There's definitely more than one wheel on that bar. And, he's where I hope to be in terms of health, mobility, training, and longevity in the field at that point in my life. So respect is where respect is due. And that does not necessarily stand in contrast to the fact that we as a field, and in any scientific field, our job is to ask questions, debate, and come to a consensus of how do we move the field forward. So I would love to get kind of your take, James, on what is the issue with periodization? More broadly, how does this connect to the way we conceptualize things? And what is the problem with calling periodization a theory in your mind? And where do we need to go?
Yeah, absolutely. I mean, I should say as well, the greatest respect to Professor Stone. I had lunch with him as well back in 2016 now, a little bit before you guys were at the International Conference on Strength Training in Kyoto, Japan at the time. And it was really nice to be able to sit and just chat with him. It was like, like you say, he spent so long in the industry. It was like sitting down with, like, grandfather Iron, and hearing his stories was very cool. And also, I don't think anyone else could rock socks and sandals and pull it off with just such flair. So yeah, absolutely. So maybe I'll give you a little bit of background to the chapter as well first, because I don't want to give myself too bad a name amongst the proponents of periodization, because I secretly didn't. For me, secretly, it's not really a chapter about periodization, which I think we'll get to. So the book itself, Myths of Sports Performance, I got invited to contribute a chapter to the book. And originally, I was actually going to write a chapter around effort and its perception, which is another topic of interest to me. But the more I got thinking about the concept of myths and the concepts of myths within science, the more I thought that this was a really good medium to sneak a little bit of philosophy of science under the noses of sport and exercise science folk without them really noticing. It's a bit like when Kiki's just walked off now, but it's a bit like when she has to have some medicine. Got to put in a little bit of cheese or something that tasted a little bit better, something that's a bit more appetizing, because most people don't want to read about philosophy of science. So it was my little sneaky attempt to do that. And if you read through the chapter, which is, we pre-printed the chapter before it went to print, so it's openly available on Sport Archive for anyone who wants to take a look. There's a few different sections to it, and you can probably get a feel for who had the bigger contributions to different sections on it. So obviously, Dr. James Fisher, Jeremy Lenicky, and Sam Buckner were co-authors on the paper, and Jeremy and Sam in particular have done a lot of work critiquing periodization from the perspective of the studies specifically that have purported to test the concepts within that kind of broader theory. And so they contributed kind of those sections, whereas my aim was really more to kind of introduce some of the broader philosophy of science concepts. So first of all, when we talk about myths, what do we mean by myths? And when we talk about scientific theories, what do we mean by scientific theories? And most of the listeners, I'll probably mention a few like names, which I'll try and sort of like not take for granted that people know who these people are, but most people will have probably heard of Karl Popper. And if you've got any minimal level of philosophy of science training in your degree level studies, then you probably will have heard of Popper, black swans, falsification, and so on.
Also, he invented the jalapeno popper, which a lot of people don't know.
Did as well, yeah. And that's the theory of how good they are has stood the test of time. Many severe tests, everyone loves them. Highly corroborated theory. But anyway, so Popper always held that most scientific theories actually start in their origins as myths. Essentially, there are kind of attempts to explain what we observe, what's going on. And typically when we think about the word myth in a kind of colloquial sense, we think of it, like you said, within the industry, people think of it in the sense of kind of incorrect beliefs that people have about what works and maybe why it works and those sorts of things. But in essence, myths are not too different from theories in that they're attempts to explain what we observe. They're attempts to kind of give meaning and structure and explanation to the world around us. So they kind of rest within what the philosophers call ontology, which is, they're trying to explain the reality that we see. But from Popper's perspective, the problem with myths and why he didn't consider them to fall into what he considered to be scientific theories was the fact that typically myths are not sufficiently developed enough that they are under his kind of criteria of what demarcates science from non-scientific ideas. And to clarify, like not everyone accepts Popper's demarcation criteria. If anyone wants a good up-to-date kind of, I say up-to-date, it's still up-to-date. The paper's like from 1983, but Larry Loudon's paper on the demise of the demarcation problem is a really, like, it's written for the layperson as well. Like, it's really easy read about the different ideas of what constitutes scientific versus non-scientific methods or belief systems or whatever, which I always chuckle at when everyone's like, science-based training is this. And I'm like, meanwhile, the philosophers of science over here have been debating the demarcation problem for millennia since Aristotle, and they still can't agree on it. But no. The Instagram and YouTube guys have figured out what science-based training is already.
The dead giveaway for science-based training is that they say hypertrophy instead of muscle growth.
Yep.
That's it. Wait, isn't it pronounced hypertrophy?
And that's when you get someone who really understands. They know that they're going for all of the trophies, especially those in the hyper.
Exactly. Anyway, so I mean, the main problem though is that at least from Popper's perspective, and if you kind of subscribe to a broadly speaking kind of falsificationist perspective on what constitutes strong scientific research, he sees it as we start off with a theory. And a theory is our attempt at explaining how reality works, whatever portion of reality you as a scientist want to be trying to explain. So for us, that's how we respond to training stimuli. That's how our body adapts. It's how we can manipulate the variables within training stimuli to kind of try and produce different responses. There's a whole host of different areas in our little slice of reality, in our disciplinary field that we want to try and explain. And typically, the more developed sciences like physics and kind of more developed biological sciences, chemistry, and so on, they have, through millennia, got to the point where they have varying theories of sufficiently precise degree that they can use those theories to then make predictions about what they should observe. And then they can design studies to go out and test those observations. And this is where from Popper's perspective, deduction or deductive logic, like the ability to say, if my theory were a true explanation of the world, then we should observe this if I do this. Like, that's just a logical corollary. It's a derivable consequence of my theory that if it's true, we observe this. And if we don't observe that, then that means the theory is not true. And so this is kind of a whole kind of simplified version of like Popper's philosophy of science, which is to say that what we do is we attempt to falsify theories, and we try and put those theories through strong tests, and those theories that survive those tests become more corroborated. We don't say they're true, but we become more convinced that they are closer to the truth, even though literally taken, any theory is false. But we hope that by testing our theories and they survive these tests, that they get closer and closer to the truth. So to go back to the theory, the periodization example specifically, when you take that into consideration, one of the reasons why I kind of say, I'm not saying that periodization is wrong from this perspective, but it's to try and frame what we would need to do to be able to say this is a scientific theory, and this theory makes very precise predictions, and we can go out and test those predictions and try to falsify the theory. So one of the problems is typically the way periodization is framed is it's a very loose kind of, I mean, it's a whole host of different kind of models and theories and things like that. But by and large, they're all very, very imprecise. So they are, you can take relativity theory and you can make very, very precise predictions about, the deflection of light as the eclipse happens. And all of these very, very precise predictions can be derived from the consequences of that theory if we take it assumed to be true. And then we can go out and make those observations and test them. Whereas with periodization theory, kind of at most often, we might be able to say we would expect that this program would produce better results than this program. Or maybe if we do things in this order, we might get better results. We're not quite at the stage, though, with it where we can make very precise predictions that we would need to be able to then design studies to actually test them. So you'd be hard pushed to go in and ask any proponent of periodization theory to say, okay, well, how much in terms of their squat 1RM on average, would we expect this group to do better than that group? And then design a study to be able to test that specific prediction that's been derived from that particular periodization model that fits within that broader theory. So the fact that the kind of quote-unquote theory is what we would call deductively infertile, it's not immediately obvious what you could deduce as the consequences of the theory, isn't one of the reasons why I kind of provocatively argue it's not quite got to the theory stage yet. It's still kind of in the mythology stage. There's other bits and bobs that go on around it as well. So I think there's still kind of some social, cultural and historical allure of kind of the Eastern Bloc success. And there are elements of like more colloquial traditional mythos and kind of things that I think tie into it as well. But other things, for example, are also things like misborrowing of auxiliary theories from other fields. And I should clarify, actually, this is actually a really good approach for fields which are still very, very early on in their kind of scientific development to actually use what is called analogical abduction. So taking ideas from other fields and basically asking the question, I wonder if things over here work the same as they work over there, particularly in fields where they've got more precise theories. So we can actually take them and say, okay, well, let's try and kind of rejig this so we can make some precise predictions. Periodization has tried to do that, or at least tried to borrow some theories, but they've used them in almost kind of like a, what's the word I'm looking for? Kind of more of a narrative sense. They've become kind of like post hoc explanations for things as opposed to being used in a kind of more appropriate sense of theory borrowing, which is to say take them, use them as scaffolding to try and build a more precise theory to then actually go ahead and test. So I think there's a lot of kind of philosophy of science, philosophical ideas and concepts that could be adopted and taken more seriously in our field, not only in periodization though, because I think this applies to the field broadly speaking. We're a very inductive field at the moment. We make observations and then we try and extrapolate from them. We may have some loose kind of theories, but they often amount to kind of, like I said before we started recording, like the A's are bigger than the V's. This group might do better than that group, which is a very weak prediction to make. The more precise the predictions a theory makes, the more risky any given test of that theory is. And then if a theory subsequently survives that test, it's better evidence to corroborate that theory. And I'm very, very much influenced by this from an epistemological perspective. So I find evidence that follows this kind of epistemological approach far more convincing than lots and lots of like small little inductive studies with all of the gamut of kind of problems that you guys have discussed recently with other guests, and you've talked about and written about in mass, like sampling variance, issues with measurement error, and these sorts of things affecting the power of our tests, and the whole host of other kind of questionable research practices, which we talked about previously when we discussed kind of open science developments. So yeah, I think I'm I feel like I've waffled a little bit there, but to try and kind of summarize things in as clear a way as possible. But I think we can do better, and we can actually. People think we're not yet as a field in a position where we can start to do science like that. But actually, I think we are. And I think we've actually got a really good example which we've presented recently, which shows we can actually do science in that kind of strong theory and deductively derived precise hypotheses that then we can then design strong, risky tests of those theories.
That's
I'm
great.
just going to share a quick anecdote, if I may. So the work I'm doing here at Duke is really pulling me out of my academic comfort zone. You know, obviously I've studied regulation of energy expenditure a lot, but I kind of split my time between evolutionary anthropology and sociology, working with more of the psychological and sociological determinants of health. And it was really exactly a testament to what you're saying. I mean, every field is going to have its own strengths and weaknesses, its own blind spots, its own kind of tendencies for better or for worse. And, you know, if you don't spend time outside of your field, you don't really know that. You just know science as it is presented to you. So the first paper that I put together as the lead author in my kind of sociology side of my work, I sent it to my advisor, who's a trained sociologist, and he was like, I like generally what's happening here, but where's all of your theory? And I was like, well, what do you mean? The introduction says, here's two paragraphs on what the problem is. Here's what I'm going to do, and the results are going to be the payout, you know? And he's like, well, but you kind of got to give me some more about, you know, why are we doing what we're doing, and what is the bigger theoretical model that's kind of underlying this whole thing. And it was that happened just like a couple months ago. It was like the first time that I realized, like, wow, yeah, there's definitely some blind spots I have just because I've been publishing in this very siloed field for a while. And yeah, it's not until you kind of peek around and either zoom out and look at more philosophy of science, or kind of, you know, embed in an entirely different field and start to say, oh, like some people really put a lot more time and deliberate thought into that theory building and model building. Whereas I think in exercise science, I've definitely interacted in circles with exercise scientists where it is often believed that we just have a need to generate data. And the role of the exercise scientist is data generation, and the utility of that data will be identified at some time. You know, but it's kind of just like, hey, we need more data. Everyone go generate data. We'll figure out what to do with it later. And so it is when you start to interact with folks in other fields, especially other fields where I'm just kind of going off the cuff here. I don't have a grand idea of, you know, I'm not really making a strong hypothesis here, but I do tend to find that my interactions with scientists in other fields, the less painful it is to produce a data point, the more emphasis there is on theory building and really strong theoretical models. And I do think that that's one thing where in exercise science, it is a laborious process to produce a data point. It is very effortful, very time consuming, very resource intensive. And I do think that may play in at like a subconscious level to this idea among exercise scientists that producing the data itself is the work, you know, because it is such I mean, anyone who's run a training study is just like, I remember, you know, my wife is, she was trained in social psychology and did a lot of survey research. And when I first found out that you can do studies where you put them up on a survey platform on Friday, and when you come into work on Monday, your data collection is over, I almost lost my mind. I had like an existential kind of crisis of like, what am I doing here? I've sunk 400 hours into this training study and I can barely see the end. But yeah, it is kind of interesting to step out of the exercise science silo and see some of these other fields where theory building really is what is viewed as the effortful process and ultimately the payout rather than the generation of data.
No, that's, I think, a great look behind the curtain of kind of how different fields work. And I get to see this a lot because here at AUT, we're under the School of Sport and Recreation. And there's a big mixture of people who fall under sports leadership and management, sports leadership and governance, and sports coaching, who primarily do qualitative work with some quantitative survey-based data like you described to support it. And then you have all the people in SES, sport and exercise science, who live pretty firmly in quantitative land. Again, like I've said many times, terrible theme park, don't go. But when we do our proposals, they fall, because they're under the same school, they fall through the same process of the confirmation of candidature. You have the same reviewers. And when you go to one of the sports coaching, confirmation of candidature presentations, they have so many slides on methodology. And that means something very specific. We don't have slides on methodology. We have a slide on methods. It's just, here's what I'm going to do in the lab. And their slides on methodology is talking about, for my work, I'm going to accept this interpretation of reality and how people interact and what knowledge will derive from it and what are the limitations and what we can and can't know. And something like, say, critical realism might get brought up. And sometimes when there's mixed methods work, the brave souls who are from SES who want to dabble a little bit in doing something like let's say a Delphi study where they're trying to get expert consensus, or they want to do, one-on-one interviews using thematic analysis to probe and get more hypothesis generating information and to give a little more experiential color to the quantitative survey they might have done. We do this a fair bit, actually, when we're trying to directly serve, say, bodybuilders or powerlifters. We want to talk to coaches and athletes. What do you do and why, and what do you think about it? Because that ensures that the quantitative answers we get are more directly applied and framed in a way that's useful to the beneficiaries of that information. We're trying to serve a community, right? So when we have to delve into there, that means we typically have to have a confirmation of candidature reviewer who's expecting some methodology. And often it's like, we're doing quantitative analysis, empirical research here, and then I'm going to try to get this right. And that's often where we really expose our ignorance. And it makes sense when you think about it. If your entire field is generating research that is based upon two people just talking in a relatively open form format, there needs to be some type of perspective that frames that so it's useful information rather than just kind of something that is an anecdote, So it's very much outside of the typical way of thinking of your quantitative sports scientist. And then to go back and kind of give an example of, what was James talking about with these scaffolding and these borrowed theories, and how do we kind of make sense of the world? In sports science, we just do a whole bunch of disconnected studies, and we look for patterns of when A is better than B. And often it's like little case A, large A, italics A. It's almost never the same A. We don't have replication studies. We have similar enough studies where we're looking for things that carry through, and then we can kind of back calculate and figure out, that probably happened this way, and it's muddied by things like we talked about, measurement error, sampling variance. But a great example of kind of how we understand this is it's very obvious that the general adaptation syndrome doesn't perfectly explain the way we adapt to training. Like there's not a very clear thing where, if you do too much, you just die, right? Which is kind of the alarm reaction if you do too much. Like, if you put a person in a vat of acid, there's going to be some responses in the body that's trying to maintain homeostasis. And if they get out, they might be better at regulating acid-base balance later if you kept exposing them to that. Or if you put them in, probably a better example than a vat of acid would be like heat exposure over time. There'll be some adaptations. But if you leave them in that hot thing for too long, they're just going to die. doesn't really work like that with like benching, you know? So we have, okay, well, that's kind of like overtraining syndrome, but it doesn't work perfectly because overtraining, that's a whole can of worms. So then we come up with something called the fitness fatigue model, which we kind of layer on top of general adaptation syndrome. And then we start to get an acknowledgement that, oh man, the biopsychosocial model actually explains all this quote unquote background noise of everything that is not going on in the gym and then in our bodies. So, okay, so we've got gas, we've got fitness fatigue, and then we've got the biopsychosocial model. And all of that together means that I don't have to be too specific, and it does adequately explain the variety of responses we have. And some of those come from within our field, and some of them are outside. And sometimes we haven't really updated our understanding of the models that are used and borrowed from other fields as they evolve. And that's a very common thing. So I think hopefully that helps people understand exactly what James is talking about. It's that type of process. But you were alluding to specifically, James, that it doesn't have to be this way. And in fact, you've done some work that is done framing it from a more theoretically grounded perspective. So could you talk to us a little more about that? You kind of left us on that cliffhanger.
Yeah, sure. Those are some really interesting examples as well. And I will just briefly mention and do a completely shameless plug for another book chapter that I've written, which is an introductory book chapter on philosophy of science, or title Foundations of Sport and Exercise Science Research, for a forthcoming research methods book that will be coming from the Society for Transparency, Replication and Openness in Kinesiology, and talks to a lot of the things that you mentioned there. So introduces students and maybe even established researchers to concepts in the philosophy of science like ontology, epistemology, axiology. I mean, did you guys get taught like basic logic when you were at school? Like for most people, they've never heard of an implicative syllogistic form of logic before. So all of that kind of stuff I've tried to synthesize and present in a digestible manner in that chapter. So that's also so openly available, and I'm updating it at the moment.
Out of curiosity, James, so like in my PhD program, we did have a series, like a 1 semester crash course on philosophy of science. I'm not sure a lot of it really stuck, but at least there was the effort on the front end, which I've come to appreciate. How did you get into this stuff? Was this formal, rigorous training that you undertook, or has this been kind of a hobby horse that you've been chasing up through papers and chapters?
It's honestly just been a bit of a hobby horse of mine, and I can't really place where it originated from. I think even early on during my undergraduate and then into my postgraduate studies, like I always had this kind of niggling thought in the back of my head of, I wonder if there's a better way of doing this. And that just kind of motivation, I think, was what drove me to then try and explore outside the field and try and understand. I've been referred to as a kind of disciplinary tourist before, because I like to go visit other fields, see what they're doing, and bring it back and pass out the souvenirs, hopefully, to our field and see if they'll give them a go. But I was thinking of an anecdote of mine as well, actually. During my we have something called a transfer viva here, which is kind of when you register on a PhD program, you register on technically what is called an MPhil/PhD program. So you do your first couple of years and they contribute to your PhD, but you can stop and just be awarded the MPhil. But you have to transfer into like the full PhD. And I remember in my my oral viva for my transfer, evidently one of the examiners had just done a quick a reading of like, what are the sort of questions I should ask the candidate? And one of them was, can you talk to me a little bit about your ontology and epistemology and what sort of philosophical stances you take? But they were utterly unprepared to actually receive a quite in-depth answer from it after I'd been recently reading Popper and Lakatos and started pontificating about them and their ideas and how they influenced my work and whatnot at the time. But it's really just been a hobby horse, and I've the more and more I've dove into it, the more and more I've loved it for its own sake. But honestly, lately, it's always had kind of like some pragmatic origins in it, in the sense of like learning this will help me do my science better, and it might help me explain to others how to maybe do their work better as well. So yeah, no formal training. So, take everything I say with a complete pinch of salt. I could be completely wrong. Probably am.
Well, that seems to be everyone who dips their toes in philosophy walks out of it saying, now, just to be clear, I could be extremely wrong and likely am. That seems to be like the hallmark of anyone who's like, I've found philosophy readings to be terrifying. I did not enjoy them the way you do. I remember maybe I would now that I'm older and a little bit more comfortable with uncertainty. But it seems like if you are not someone who gets a weird sense of intrigue from uncertainty, philosophy readings are one of the most painful experiences that you could ever find between pages of a book or article.
Can I just say, though, I do think it's important, especially to be part of a graduate program and framed in the right way. I wrote an article for Mass called basically on pseudoscience and what to do about when you see it and whether it's misinformation and disinformation. And in my readings to write that article, one of the things I came across was a study, and, not a great study from the framing that we just had, A versus B, which is better, but they looked at two different graduate programs that were otherwise identical. I think they might have been from different years or similar programs that had one change. And in one, it was your typical methods class, which is what I had. So I didn't get introduction to philosophy of science outside of some of the stuff within the quantitative realm or of what's correlation, what's causation, frequentist stats, et cetera, right? So it's embedded in there, but it wasn't intentional. And when you compared students who were given this methods class or this design class, if you will, versus those who were given specifically a logic class, and they measured the number of what they called untenable conspiratorial beliefs. So it's not just saying, oh, you believe in something that the internet says is a conspiracy, but things that you hold two beliefs which actually contradict one another, that shouldn't be able to exist at the same time. The methods class had no influence on that, but by the end of the philosophy class, those actually reduced. So this is actually teaching people to be better thinkers, and it's one of the reasons why we often see people who are academically robust in their background, or may even have what you would describe as like high intelligence, if we think of it from just a kind of a raw processing power, but have some errors in their critical thinking. So I think a prescient example of an untenable belief, just so people know what I'm talking about, would be to say there's a global multinational conspiracy against, say, health, or something like that. The medical and scientific establishment and governments are doing something to they have bad intentions for us to control us through health or nutrition or something like that.
To keep people unwell.
Exactly. You might hear it about the dietary guidelines, for example, or you might hear it about the way we deal with infectious disease. Very common during the COVID era. The same person will often then state that the governments are incompetent, they're not using good evidence, they're unable to roll out these things, what they're doing are ineffective, and you don't get to state that the same entity that can maintain a global multinational conspiracy across political lines, geographical lines, and even non-governmental agencies and dealing with individuals in the medical and scientific establishment is able to do that, which is a huge effort and burden to be able to do, as well as being too incompetent to do the basic function of government. You can choose one, but you can't choose both, right? That's an example of having those untenable beliefs, because if you don't understand logic and if you have strong emotional ties to something, it's very easy to not even tap into your own critical thinking skills. Although they may be well developed, you may have them, but if it's just simply, oh, I have a prior belief, I know I'm right, I have a conclusion, and let me work backwards, and I'm going to just give a thumbs up to anything that supports it, then yeah, I'm good with both of these because they both prove my point without noticing that contradiction. And I think that is how we often see people who, in other facets of their intellectual, ability to exert processing power, they're really quite good. But man, when you get them on something where they have an emotional attachment to it, they don't even go there to try to see how they can apply those logical skills. So anyway, I think this is a very important topic. That's just an example. So carry away from there, my friend.
Yeah, James, we got to get into this study. We've been teasing it for a good 40 minutes here. So let's dive in.
All right, let's dive in then. Well, let's get the main, well, the thing that most people have paid attention to out the way, because from my perspective, that's really the least interesting thing about the study. I mean, you guys have talked about it already on the podcast, and this is the Gschneidner et al. Study, which was a collaboration between myself and Dr. James Fisher and Luke Carlson and David Gschneidner from Discover Strength. We've collaborated with Discover Strength a bunch of times over the years. We've always really enjoyed working with them, and I'll come back to this at the end, I think, as well. But I should say that generating collaborations with external industry partners who are in a position to be able to deliver on these kinds of studies is really key, I think, to be able to push the fields forwards and step away from the typical kind of, like I say, the data generating emphasis is partly because of the systemic constraints on being able to do these big studies. So it's just easier to just chuck out studies of, N of 20, N of 30, and that's that. When everyone secretly knows that that is woefully underpowered for anything that we could possibly be interested in the field. It's also partly why, and this will touch a little bit on what you were talking about there, Helms, some people might see it as a set of contradictory beliefs I hold, but I'm hopefully going to explain why that's not the case. Like, I typically put almost zero stock in the results of any given individual study nowadays. This one is an exception, not just because it's my study, but for the reasons I'm going to talk through. But for most studies for me nowadays that come out in the field, I look at as basically fodder for meta-analysis. And that's actually a really noble pursuit. And, if you look at, for example, Daniel Larkins has a wonderful paper on sample size justification. And sample size justification doesn't have to be statistical power or statistical precision based. It can be, this is all we can do in the constraints we have, and we're not going to make strong inferences from this study because of those reasons, but this is going to contribute to cumulative evidence generation and allow a future researcher, might be us, might be others, to be able to perform robust meta-analyses and other evidence synthesis approaches with this data. Anyway, so the study was on, it was another lengthened partial study. Let's get that out the way. But like I say, the lengthened partials...
Another one. Good grief.
Yeah. I mean, from my perspective, this is like the lengthened partial study. I don't know why anyone will want to do any more, but... Anyway, the key points of the study, which I think lots of people have overlooked, are exactly the things that we've been talking about. It almost wouldn't matter what the two interventions that we looked at in the study were from the broader points that the study is able to present. So to start off with, let's work with this idea of a strong theory. One of the, and this is a very simple theory actually, and sometimes in fact, again, like one of Popper's kind of values with regards to kind of theory development was it needs to be, as simple as it can be, and or no more complex than it needs to be essentially. The simpler the theory, the better. The simpler the theory, the easier it is to derive predictions and generate tests of them. And this theory that I've been kind of working with and kind of developing and thinking about is just simply a theory about how humans adapt to exposure to resistance training over time. Like, what does the shape of adaptation over time look like? And I should also say as well, this is also why a lot of the data generation and at the early stages of science, that inductive approach of kind of saying, making observations, trying to generate generalizations and explanations from them is important, because I've had to do that or had to stand on the shoulders of giants and work with the evidence that others have produced to be able to get to the stage to be able to generate these ideas and theories. So we've done a lot of work looking at strength adaptations in large data sets, and we've also done a lot of large-scale meta-analytic work as well. And when I say large-scale, this is like 100-plus studies. This isn't your typical kind of, you might get 10 studies in a meta-analysis. These are large-scale meta-analyses. But consistently, what we see is that the adaptation, a model that fits the results that we see over time with respect to hypertrophy and with respect to strength, albeit the magnitudes differing, is a logarithmic adaptation over time, or approximately logarithmic adaptation over time. So you see rapid gains in untrained populations that start to kind of plateau out, and eventually, I mean, technically speaking, a logarithmic model never actually plateaus.
It is an asymptote.
Well, also, if you include a linear term in there, like you would in a kind of quadratic model where you might have a linear and then a squared term in it, you can have a linear and then a log term in there as well. And then that does allow the model to fit a plateau. But approximately speaking, it is essentially a logarithmic model, or at least that's what we've generalized from these large-scale meta-analyses, these large-scale data sets that we've worked with. And we've also, from those meta-analyses, then got empirical estimates of what the magnitudes of effects should look like over time as well. And I've come back a little bit, actually, to because one of the examples I've given in some previous work is, for example, the fitness fatigue models of in the field, to say, look, in some places there have been attempts to come up with more precise theories. One of the problems with the fitness fatigue models, though, is oftentimes the model is fit to the data rather than selecting parameters and then testing whether those parameters are actually, falsified in the data or not. So there's some kind of weaker applications of model there. But with us, what we did is we essentially said, right, look, we've got, we know roughly from these large-scale data sets, what the magnitude of change in hypertrophy should be over time as a standardized mean effect. And for strength over time. And you're looking at approximately like a 0.34, let's stick with hypertrophy for the moment, 0.34 standard deviation units change over a 12-week intervention in untrained populations. Okay. Now,
I just want to highlight that because, like, when we were talking about, we had a whole episode where Trex and I talked about, and he helped me with this article, the impact of sampling variance. And the example I used was, what if something's just on the borderline of quote-unquote trivial to small of 0.2? And I think to understand that the effect of training, period, in an untrained person has a 0.34 effect on hypertrophy tells you that, yeah, I went with 0.2 because it is in our field, the threshold, or not even our field, generally accepted as in that family of effect size of the cutoff from trivial to small. But realistically, 0.1 might be a more realistic thing in a non-untrained population with differences in training, because we're talking about untrained compared training to nothing, right?
This is the main effect of training. So this is like the causal effect of, and bear in mind, this is estimated from meta-analyses where the protocols do vary across it. So there is some between study variance, and there's evidently characteristics like protocol and things like that. But this is also partly why, when I get to the results of our study, I'm even more generally convinced of the general theory. But also, yeah, to put it in perspective, if you were to just do a simple resistance training versus control group study looking at these effects, or even let's make it even simpler. Let's say you just do a single arm study and you're looking at strength changes, or any changes as a result of resistance training intervention.
Although strength changes are higher. Strength changes are
higher.
Yeah.
But you would need, in order to be able to detect like the smallest effect that you would be able to detect with a 50 participant sample is about a 0.4 standardized mean difference. So even just to detect and this is controlling error rates or having a precise, pre-specified degree of precision that allows you to exclude 0 as a possible effect. Like you're needing 50 plus people just to detect the effects of resistance training on hypertrophy. So it highlights like the effects are small. How small is, dependent on what's small to you, but they're certainly smaller than any of our typical studies are designed to detect. Then you get to the problem, which is exactly what he said, which is, we are mostly not interested in whether lifting weights makes you bigger or stronger, because we kind of know that. Like the meta-analysis data showed, like it's a real effect. It's a small effect, but it's a real effect. Like, we don't really need more research to tell us that. What we care about nowadays is, does protocol A do better than protocol B? And so what we're asking are interaction questions about the differences in differences over time. So one of the things we did with this study was we took our theory of a linear logarithmic growth and we said, okay, well, if that's the case, in trained participants then, qualitatively, that means that the magnitude of changes, if this model is if this theory is accurate, have to be smaller. Okay, well, if we know what the changes are over a 12-week period and we know that it's a linear log model, then we can just predict what we should see as the main effect of resistance training over time. And then from that sets a mathematical constraint on what the possible interaction effects magnitude can be. Because if the average, an interaction effect is just I'm not sure which way my hands are going now, it's just the difference in kind of slope, so over time. And so if the average effect over time is this, then to have a interaction effect that is bigger than the main effect of time, you have to have like completely like opposite. You have to have one intervention that actually makes people lose muscle and one that makes people grow muscle. Whereas like no one tests any. We all know that continuing to lift weights doesn't make you lose muscle at the very least, assuming you're not, a very elderly population and aging is catching up with you and overtaking. So all of these things, and this is what I mean by precise theory, these things start to very much constrain the predictions that we can make about effects that we look at. So we essentially had this linear log model, we had estimates of the magnitude of effects that we can see over time, and then from that we can deductively derive what we think the estimates for the main effects of time should be for participating in a resistance training intervention of a given duration for people who have a given level of training experience as well. So if you take that model and you say, right, at 0, you're untrained, and we want to look at the effects of whatever 12 weeks, well, it looks like that. But if you start with whatever 6 months training experience, you're starting here, and the effects are like that. They're tiny. So we essentially took from that theory precise predictions, and not to disappoint people too much, and this is kind of getting at why everyone thinks I'm really black-pilled, which I kind of am, but the magnitude of effects that we would predict in hypertrophy, and this is the main effect of time, so again, this is just from training, is 0.05 standardized mean effect. So it's pretty damn small. Then if you take into account that interaction constraint, like we would say that like it's maybe reasonable to expect a difference between two interventions to be at most maybe half of that, so 0.025 of a standardized mean difference. So we're talking about very, very small effects.
Can I add one thing?
Go for it.
Just to contextualize this for people who are, these numbers might not mean a lot. A cool thing about some of the recent meta-regressions that I've been either privy to or involved in, the ones that Pelland and Robinson have led on proximity to failure, as well as total sets, indirect sets per muscle group per week, and also the one that Trexler and I are part of, led by Dr. Martin Refalo, on protein intake and modifications of lean mass in a deficit, to get to the point where you are seeing this small effect, which is actually quite large in comparison to the effect of resistance training on an untrained person, which is like 0.34, which is like in the middle of between small and moderate, closer to small. You have to have some pretty big disparities when you look at kind of the predicted regression line. So for example, I think in Robinson, so I was looking at this, if you look at the specific figure where they're comparing failure all the way to 10 RIR, the difference between like a 9 RIR and failure is where you get to like that roughly small effect difference. And I think in the Pelland meta-regression, I want to say it's like a 15 set difference.
Oh,
so
pretty big, yeah.
Yeah. So, and then in our protein analysis, it was the difference between 1 gram per kilogram of protein and 3. So this is what it actually takes for us to observe what we would be relatively modest effects compared to other fields. So when we're talking about, hey, I want to compare 10 sets to 15, or I want to compare 1.5 grams per kilogram to 2 grams per kilogram of protein, or I want to compare a 2 RIR to a 0 RIR. This is why it's so important for us to have meta-regression, have meta-analysis, to have these large-scale multi-site data collections, and also just to temper our expectations for these reasons. So anyway, I'll let you go from there.
Yeah, and one of the things I'll add as well is because this is where like I thought this for a while as well. Well, now as we're moving into an era where we're starting to capitalize on the fact that we've got a lot of individual studies now that can act as kind of like fuel for our meta regressions, and we're shifting into a phase where we're starting to ask more appropriate questions, I think, regarding dose response relationships. You do hit a problem with the meta-analytic method of building these dose response models, which is the same as you have with the individual studies, is that the data already exists. And unless you pre-register testing a specific model's functional form in that data, it's not necessarily a severe test in the kind of risky, Popperian, falsificationist perspective. So the way I kind of think about these meta-analyses a lot now is they're still like, from a practical perspective, you should still probably use them to inform what you're doing. But from a theory building and scientific perspective, that's what I see them as. They're now the kind of best evidence we have for this is our theory of what we think the dose response looks like. And you can think of like the models I'm talking about as dose response models, and dose being how long you have trained for, how much of the training dose have you received over time. But then we can use those to then plan strong studies to test the predictions of them. And that's exactly what we've done here. The next point I was going to make, though, is evidently, as I've said, like these predicted effects were really small. And so one of the things I pointed out when we were designing the study was, look, if we're going to try and design a study that's going to be able to detect first of all, a main effect of 0.05 at least, because that's what we predict. So we need our study to be powered at least to predict that. Even if it turns out the effect is bigger, that's what we're predicting. So we've got to design our study to detect it. It's going to be even more to try and detect the interaction effect comparing to interventions. So, and when I was running the simulation-based analyses to determine the sample size for the power that we were looking for in our study. And I should say we powered the study for like 95% power as well. So it's a higher power than typical for the field. We set our alpha level at 0.01 as well. So I was deliberately trying to be like really like on the nose, like come on guys, like you can do it, but do it really, really stringently if you want. But to put it in perspective, if we were going by the simulation-based results for detecting a difference between the two interventions, we would have needed like 1,000 plus participants in this study. And that was just never gonna happen. Like, at least from our perspective, that didn't feel like a useful use of resources, even if I just wanted to make the point of saying you can do big studies if you try really hard, guys. So instead, we not only took these theory-based predictions, but we also then layered in the practical considerations as well, because we kind of said, look, if our theory predicts that the effects are this small, are these predicted effects even big enough for anyone to care about? So credit to Milo, Dr. Milo Wolf, and to Dr. Brad Schoenfeld as well. I thought, you know what, I'm going to pick two of the guys who I think are the most optimistic guys about hypertrophy and the effects of different interventions, and ask them what their smallest effect size of interest would be. So we set a smallest effect size of interest from a practical perspective as to what would be considered meaningful, which was bigger than what our theory predicted the effect should be. And so what we did is, in terms of our statistical tests in the study, we actually designed the study to test for equivalence within that, because our theory predicted that the effect should be within that 0.1. We were predicting a main effect of 0.05 and an interaction effect of 0.025. So that's what we did. We designed the study. We powered the study to be able to detect that. We had just shy of 300 participants. We collected data over 15 different sites, and Discover Strength did an amazing job being able to do this. We've done previous big studies with them as well, where we've done a similar approach, where we've kind of made predictions about what we think the magnitude of effects might be for fat loss, for example, between heavy and light load training, which was another previous large-scale study that we've done with them as well. And also then tested for equivalence, because we weren't expecting the differences to be huge. But it goes to show that, you can design these studies and do these studies if you collaborate appropriately. And that doesn't need to be with industry partners. This could be multi-site collaborations across different labs. I think Dr. D'Souza recently kind of extended his offer to collaborate on that. I should say as well, now I'm working out in industry with Kaiser Australia. We're in the process of really building our infrastructure out to be able to deliver trials within the kind of resistance training space. We work more with kind of clinical populations, but these large scale kind of collaborations are really key. But is it worth jumping onto the results, or do you want to jump in with anything, guys?
Helms, I can't hear you. I think you might be muted.
There's a good example of a study that you did kind of modeling the long-term growth response. I want to say it was like in 15,000 participants. Was that Discover Strength as well, or was that Kaiser?
No, that was with a Dutch company called Fit20, actually.
Okay. So another example of a really good collaboration. And I think you found that there was like a top end of like a 40 to 60% increase in strength before you started to see what you could describe as a plateau or severe diminishing returns. Yeah. And I found that really interesting because it really does depend upon kind of the effectiveness of what you give people. Because if you told me someone's strength who was untrained increased by a maximum of 50% over years, 2 years, I think, or 7 years, it might have been, that's right, I would look back at Hubel and colleagues' study, which is one of the classic papers in our field that had just short of 600 participants, multi-site data collection that was looking at, I'm not going to say individual response variation, I'll say differences in response of people. And the average response was that much in 12 weeks, but they had a much higher volume protocol. So the only critique I would give back is that I think when you're looking at low dose resistance training, we know that the effect can be quite even more small, which can to some degree kind of dampen it. Okay, I'll take a step back. It really depends upon who the community we're trying to serve is and what message we're trying to give. Low dose, high intensity resistance training is probably the most likely adopted and useful intervention for the general public. And that's why it's interesting, because it takes minimal time investment. You get in, you get done and dirty. Obviously, there's some psychological questions as to someone, would they prefer to do 4 sets to failure or 12 sets shy of failure? If we pretended they were equivalent, that might be personality dependent. But certainly from a time efficiency standpoint, you'd want to do the 4 sets. But when it comes to sports science, where a 0.1 difference in, say, your 100-meter time is the difference between being an elite level sprinter or pretty good, or when you're talking about any visible change, that could even be due to not consuming enough carbohydrates before you get on stage and dropping 2 or 3 placings on, in a sport like that, is a very different question, isn't it? Like, what do we care about? And I am sometimes curious about, like, what's the maximal effect we can get out of this resistance training, not the typical one, or what should we expect? Because I'm interested in the sports science side of it. Like, if we get a whole team around, if we get kind of like a NASCAR pit crew around somebody and try to optimize every little opportunity, what does that look like? And that is a very different question to how do we improve population level health through resistance training, right? So I just wanted to make that small commentary.
Yeah, and I think, so we touched a bit on this before we got on air as well, is there's often some kind of confusion between what we're trying to do in research typically, which is to estimate the underlying causal effects of a particular intervention when we're looking at it. Versus kind of like say some of those observations you might make, someone drops a place on stage or whatever, and they might ascribe it to a particular set of things, but ultimately that is kind of like the single observation that you would see of a participant that is the consequence of a whole complex data generating process, some of which might be the causal effects of the interventions that we're interested in. And within a research context, this is where we're interested in trying to determine what the magnitude of those underlying causal effects are. On average, granted, although as we kind of touched on beforehand, I'm sure you'll get Zach on at some point, and he can black pill everyone on the inter-individual response variation stuff. I'll leave him to do that. But I guess to kind of go back to, like, this is where, like, I'm granted, there may be very, very small differences between the different interventions. And, like, hands up, I've been a low volume guy for a long time. I train typically like that. I've got no aspirations of standing on stage or competing or anything like that. Haven't got the genetics for it. But
the genetics aren't a thing. Everyone responds with the same, James. So come on.
Yeah, but they affect your starting point, unfortunately. So mine's shit.
Maybe.
But one of the reasons, again, so the Fit20 data is an interesting corroborator, and I'll get to why I think our study is an interesting and strong corroborator of the general theory that resistance training adaptation over time is approximately linear logarithmic in its functional form. So if for example, we look at the and it was that Fit20 kind of data alongside other data sets such as the meta-analysis data sets that we worked with that influenced this kind of theory development. If we look at, for example, the 12-week strength standardized mean differences from our large meta-analysis data set, and again, this is resistance training in untrained populations against control groups. The vast majority of these interventions were your typical kind of 3 sets per exercise, 10 reps to failure, like considerably more, not high volume by any stretch of the imagination, but also considerably more than the 5 exercises, 1 set to failure once a week that the Fit20 guys were doing. We see a standardized mean effect of about 0.89 in the meta-analysis data, and it varies across the exercises we looked at in the Fit20 data. But the standardized mean effects that we calculate from that data over a 12-week period are not far off that. They're in that same sort of ballpark range. Taking into account we would expect to see some variation in anyway, given a random sample of exercises and whatnot. And so, I still kind of fall along the lines of in general, the differences are probably very small. But if you are in a if you're competing, like, you want to bet on what's going to get you the most. And as much as I'm going to hate saying this, because I think it's license for something that people in the field have been shifting towards doing that irks me massively already, everyone kind of has jumped on the bandwagon of like bashing significance or null hypothesis significance testing and misusing it and shifting towards kind of estimation based and confidence intervals, by which they mean I'm going to calculate a confidence interval, ignore that confidence interval, and then just interpret the sign of the mean value. So if it's positive for one intervention, I'm going to say that intervention's best. So but technically speaking, maximum likelihood estimator, the sign of a mean effect between 2 different groups, is an unbiased estimator of it. So, if you were playing the long game, if you just bet on the intervention with the higher mean effect, in the long run, you wouldn't be right every time, but in the long run, over a lifetime, you might come out on top. So I'm gonna hate that I've probably just given license for everyone to just ignore the statistics and just interpret the point estimates now, but anyway, but if we go back to the study that we had as well, I'll brush over the kind of interaction effect results that we looked at, which were the main point of the study was to test lengthened partials and full range of motion training. And surprise, surprise, they're basically statistically equivalent within that kind of 0.1 smallest effect size of interest limit. But one of the interesting things that we did is we calculated the main effects for time for strength and the main effects for hypertrophy, and we compared those to the very precise estimates that we took from the theory-derived models to begin with. So we predicted an effect of roughly 0.05. There's a kind of very small, precise interval around that. And for strength, it was about 0.12, I think, off the top of my head. But when you look at the main effects for time for both hypertrophy and strength, the estimates that we got in our study were damn close to what we predicted precisely from that model, that theory of linear log growth over time. You take a trained population of 6 months, you train them for 12 weeks, and we would expect them to grow by about 0.05 and to gain strength by about 0.125 or whatever. And those estimates that we got were really damn close to it. And I'll put it in context a little bit more as well, because if you take Popper at like face value, like technically speaking, take for example like the strength data that we had. I've got it open just so I can have a look at it. But if you look at the chest press and leg press outcomes that we had for strength, like the interval estimates from the study exclude the predicted value from our theory. And so strong Popper would say like, you falsified your theory. That's it. The reality is we know that's not quite exactly how we end up using falsifications in science. It's not like strict black swan approach, and this is why like Popper's students like Imre Lakatos kind of developed and worked on Popper's work to kind of talk about this kind of softer methodological falsificationism that he uses, because it could be that it's not the theory that's wrong. There's various auxiliary hypotheses and things like that. But one thing that Paul Meehl, who again, I would definitely encourage anyone interested in philosophy of science to read everything that Paul Meehl's written, because he was a polymath genius, clinical psychologist, philosopher of science, just all-round awesome guy, who also strangely looked uncannily like my granddad. Like the likeness is scary. I showed my nan a picture of Paul Meehl once as a joke, and she went, that's a nice picture of granddad. And then I had to explain to her it wasn't granddad. But one of the things he kind of worked on was this idea, was developed some of Popper's ideas of theory corroboration, because, near misses to specific predicted effects from theories are almost as strong corroborators as hits themselves. If you're way off in your predictions, then like it's so the idea of all of this is like calling your shot. But when you're calling your shot, you've got to take into account how big the area that you could hit is. The example that Meehl gives is a really nice one. So he says like, imagine I've got like a theory of the weather, like I've got some theory of rainfall, and I tell you, it's going to rain next April. My theory predicts that, and it rains next April, and you go, okay, well, it's pretty good, but like you had like, multiple days that you could. It's almost like like you run lots and lots of
accuracy level is not meaningful to us. If you can tell me within a 30-day window it's going to rain.
Exactly. But then I say like, okay, it's going to rain at least 7 days in April. And it does rain 7 days in April. And you go, oh, okay, it's a bit more impressive. And then I tell you exactly which 7 days it's going to rain. And it does rain on those days. And you think, oh, this has got something going for it now. And then I tell you on those 7 days, it's going to rain, half a centimeter, 3 centimeters, and give you all these precise predictions. And boom, 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 I get 5 out of 7 of them right. Like, you'd be pretty damn impressed by how good my theory is. Like, taken strictly as true, we know it's false, but it's pretty damn close to the truth if I can predict things with that level of accuracy. Also, we think, and this is where he came up with this idea which he called the Spielraum, which is a German word which means like area of play or play region. And so one of the things I actually did with our estimates was to calculate something that Meehl worked on, which is called the corroboration index, which ranges from 0 to 1. If your estimates are bang on your predictions, then you get a 1. Whereas if they're close to it, then you get, the closer to the one the better. But it takes into account this possible range of values that you could get if you didn't have the theory to make any predictions. And so one of the things we did is we went back to the meta-analysis data sets that we've got. And in those meta-analysis data sets, we can calculate a prediction interval, which is just the interval that tells us if it's a 95% prediction interval, 95% of future studies should produce effect estimates for the effects of resistance training over time on hypertrophy or strength that fall within this region, which is actually quite a big region when you look at those prediction intervals. So we had quite a big region. We made a very precise prediction, and the estimates were pretty damn close to that predicted effect. So this goes back to kind of what I was saying of I don't think it's contradictory necessarily, from my perspective at least, to say I don't put a lot of weight in single studies, but I do put a lot of weight in a single study if it's a very highly powered, strong test of a very risky prediction from a very precise theory, and the estimates come out as pretty damn close near misses. So all of that is to say, there's a reason why I feel I'm relatively black-pilled and everyone hates me.
I think it makes a ton of sense. And it's, Trex, you have specifically spoken to this, that meta-analyses are the best evidence we have with a whole bunch of caveats. And there is a strong argument in the field where these are rare and they don't happen to take a appropriately designed, theoretically based, high sample size study that is powered to detect something that you were predicting as even stronger evidence than a meta-analysis that may or may not in our field even have that many participants. So as an example, there's 2 drop set meta-analyses right now that we have. And in the bigger one of 6 studies, it's got just under, I think, 150 participants, which is half of what you got in this one study. So if this was, say, not a lengthened partial study, but a study on drop sets compared to traditional sets, I think you could make a strong argument that you would actually care more about the outcomes in that single study rather than the meta-analysis on drop sets. Am I wrong, Trex?
No, I mean, I think that's, I mean, if it weren't done by such disreputable characters, such as Steele and his colleagues, then yeah, in theory, I'd say, yeah. I mean, and that's another thing, though, is like meta-analyses, especially when they're on training related, or just any outcome impacted by training. One of the things that is always going to be an uphill battle for our field is, you get these relatively small meta-analyses. Like my wife, her research was on smoking cessation. They do a meta-analysis. They have 10,000 studies. You know what I mean? We have 11. And you start going through these and you're saying, like, for example, Helms, we're looking at the effect of a lot of protein versus kind of a lot of protein. And you're looking at these different studies and they have completely different populations, different age ranges. The nuts and bolts of their training programs are fundamentally different. And yeah, I mean, if you tell me that I can look at a single study that calls its shots, has a really large sample and has everyone actually doing the same thing and falling within the same window of kind of eligibility criteria, you can make a very, very strong argument for that.
Yeah. Now we're not having to quantify the random effects and study heterogeneity to say, yeah, we know that this effect occurred. By the way, only a very small percentage of this effect is actually related to the manipulated variable. The outcome change is related to, 85% due to study heterogeneity. But hey, definitely eat more protein. It's a tough thing. And
Or you get people up in our DMs telling us we should have accounted for all the covariates at the same time in the model, which we had just zero power to do. Our ability to even estimate the effect of those covariates was basically just randomness, just based on the small number of studies with each element. So yeah, it's like you get in this situation where it's like, yeah, I would love to put all these studies on equal footing across these different estimated confounders and covariates, but I can't even estimate the effect of each covariate with any degree of confidence,
Mm-hmm.
People don't realize those, once you cut things up enough, those cells end up with like one or no studies in.
Exactly, yeah. And I honestly, I want to go back in time and figure out who is responsible for saying we statistically controlled for blank. I understand where it comes from, but man, some people lean on that so hard, and they're like, well, it's like when I was a kid.
It's like saying it's a tax write-off, but you don't know what you're talking about. Oh, it's a tax write-off.
No.
What do you mean by that? Yeah.
When I was a child, I did not understand that, when even young people won't even have a context for this, but back in the day, we wrote checks. You'd be in line at the grocery store and you would get out a sheet of small pieces of paper and you put a pen to it and say, what's the damage here? You write the check. When I was a little kid, I didn't understand that those checks had any connection to an actual bank account. I thought the government just issued people like 100 little pieces of paper and said, hey, whenever you're in a jam, just use one of these. Doesn't matter what the cost is. And you can just write down whatever number you like. So my mother would take me back home from like whatever I was doing when I was in, kindergarten, whatever. And I would try to get her to go to McDonald's and get a Happy Meal. And she'd be like, oh, I don't have any money, which at the time probably just meant shut up. We're going home. And I'd say, just write a check. I know you got checks. And I had fundamentally no understanding. Just write the check. And I feel like I get so many DMs that are like, just control for it. And I'm like, why didn't I think of that? Control for it fixes it.
It's that easy. So,
and you could get into a whole nother deep dive session at some point on causal inference and control and regression models for that.
and we won't do that, dear listener.
No,
But
we won't do that right now.
I do want to ask you prospectively. I think it would be interesting, and I almost want to go down this rabbit hole of, what does it mean to have a linear log model based upon a given dose or a maximum potential? And I don't know if you understand the distinction between that, but one of the reasons why I brought up that analysis of the linear log finding in what's the name of the group? True Strength? I'm sorry, I forgot what it was.
Fit20.
Fit20. Yeah, Fit20. Yeah, that data set where they kind of capped out on a improvement from baseline of 60%. You observe that same linear log model in some of the data by Latella in powerlifters. But these are powerlifters who are starting, as what we would describe well-trained, at a higher strength level than the people got to through 7 years of training in that study. And they still make a linear log progress and are probably somewhere close to plateauing. And I think, if you think about it, like if you have and I actually have data on this, if you have your average, let's say 93 kilo male who is starting that with a 500 kilo total, let's say in the open division in 2024, they're getting in their powerlifting career, they've been lifting for 3 years already, they are probably going to, on average, get to around a 600 kilo total. And that is a gulf of distance between the strength level that we saw in that other study. In fact, if you think about the level of strength improvement they had in that 15,000 person study of just one set per exercise, they never even got to what we would ascribe as an intermediate level, despite training for 7 years to failure on these lifts. So it makes you wonder, is there a dose constraint? Like, yes, it might follow a linear log model at a given dose, but there's probably also some ceiling effect or something that approximates a ceiling effect if it's an asymptote, depending upon how much is someone willing to invest in terms of time, effort, and, kind of the area under the curve of training. So that could be a whole can of worms. But I think it's an important one to acknowledge, because in a health perspective of exercise intervention for the public, we kind of have to go, okay, what are people willing to do? Because perhaps doing 30 sets to failure of highly effective resistance curve training while taking creatine, 3 grams per kilogram of protein, optimizing sleep, and doing everything in your power to make sure you have a great recovery environment, and then possibly looking at some pretty strong self-selecting behaviors of, I'm going to do this because I'm actually getting a decent baseline response, is very different to what do we think the average American will do if we can teach it, deliver it, show them in a way, and make access and create every incentive and remove every barrier as possible. And that is why I do think it is so important to have exactly what you're talking about, James, is a strong baseline theory. What are we expecting, for whom, and why? And that is what we're talking about. That's ontology, right? The why are we doing this and why do we care, I think, is a very important piece. And you see this on social media. Like, I actually had a comment today on the post that we made on Mass. And Trex, I had a slide in there, like, are you actually advanced? And I described the rate of progress that a novice, intermediate, and advanced person would make. And I even showed some curves from studies showing that kind of linear log effect. And I mentioned in the description of novice, intermediate, advanced that most people never become advanced. Most people are lifelong intermediates if they lift for their whole lives. And someone commented and said, why is that a bad thing? Like, I'm totally fine with being strong and healthy and regularly training and knowing that it's a beneficial thing for my health. And I said, you're 100% right. But again, this is Mass Research Review, and more so, it's Eric Helms in Mass Research Review. So my audience are people who are like, I refuse to accept the black pill. I will discard that, and I'm going to see what I can get. And I think that
like
truly,
James's cat, getting that pill out of the cheese, discarding the pill, and eating the cheese.
Exactly. And I think that is sometimes the stance I take with my audience is like, okay, but I'm also going into it, I would say, I'm not being unrealistic. From my experience in the field as an athlete, I know that if over a 2-year off season, I can increase my stage weight 1 kilogram, that's a big deal. But that simply doesn't even get captured in the types of things we're talking about, unless you have all these things in place and you do these multi-site data collaborations. So I guess with that framing, if we want to move forward, both in public health as well as in sports science, what do we need to do to try to capture some of these small differences to see what's actually possible? And how do we advance the field so that we're not just getting a bunch of these A-B comparisons and maybe having a meta-analysis 10 years down the track, which is helpful?
And also, sub-question before you get to those, James, do you think we should try to identify these small effects?
Those are great questions. I will say very quickly as well, because actually in that, one of the things that prompted us to work with Chris Latella on the open powerlifting data set was one of the things that I did during the Fit20 study was we actually pulled out a bunch of other data sets as well. And we did take a random sample of, I think it was 10,000 lifters from the open powerlifting data set to explore those models. And this is where I think I think for your audience as well, I love the way you frame things because you're exactly right. Like I'm not really like black belt. I've kind of lent into the character because Zach's pushed me into it. And I do get curmudgeonly and grumpy, but I'm not black belt insofar as saying nothing matters. I'm not nihilist. I've got an ethos, like for any of the Big Lebowski.
Big Lebowski, let's go. White Russian.
Well, it might be going now. But the interestingly, again though, like one of the things I think is, like you say, typically most people who are in that open powerlifting data set, they've lifted. No one just jumps into powerlifting and competes straight away. Maybe some people do, but the vast majority, you can make the reasonable assumption that they've lifted for some time beforehand. I did just quickly pull it up while you were talking there, just so I could check the actual figure. But similarly, we also calculated the 12-week standardized mean change for the powerlifting data set that we took as a sample in the Fit20 data set. And that was about 0.22. So again, it's not too far off what actually we were sort of predicting from even say like a 6 month, after 6 months of training. But I think as well,
but that's in well-trained lifters.
It is in well-trained lifters. I also think as well, there's a uniqueness to a powerlifting context, going from like I lift weights in the gym to I'm going to specifically practice these 3 lifts and get really, really good at them. Which I've had in the past. Like, I've had periods, like a decade or more ago, going out now of going like, right, I'm getting my squat up, I'm getting my deadlift up, I'm getting my, bench up. And I can make pretty impressive gains on them. I like if I wanted to now, like, yeah, I could probably push my deadlift up more, but I'm getting old and trying to not hurt myself as much nowadays. But yeah, so I think there's a context in which actually, like the quote-unquote black-pilled Steele theory of linear log growth, our linear log overlord, as Zach keeps calling it for me, is present. But that doesn't mean, again, it doesn't mean you can't continue to make gains. They just become harder and harder and harder. And I think if you're in that audience who are interested in competing, you're interested in trying to optimize, then it's a healthy mindset to push the limits and test and play around with things. But like I say, I think you do a really good job of couching it within a set of realistic expectations of that this is generally what happens. It's going to get harder. Give it a go, see where you get to, play around with things, enjoy the process, and, you'll get what you get out of it. But anyway, to get back to the questions, I guess then, I think I think let's assume that it is worth doing these studies to begin with, and then I'll get to that question. I think some of the key things we need to do is to start with when we are planning studies. And I'm gonna, I don't know if Franco will appreciate this, but for those who don't know, Franco Infelizzeri, he is editor-in-chief for Science and Medicine in Football. He is a very, very highly regarded professor in the field of sports science, done a lot of great work. He's also a friend of mine and very strong proponent of open research practices as well. He's really elevated his journal to, it's a Q1 journal now, one of the first to, I think, if not the first to start offering registered reports. mandatory approaches to open data and code and things like that, all the good open science stuff. But he actually made a suggestion that we're going to explore also as an option for some of the journals I work with, of a new type of publication format, which is essentially, if he gets submitted a lot of studies that are typical for our field, which are underpowered, or they've just got no sample size justification or whatever. And we know why that's the case, because the vast majority of research is done as master's projects or PhD projects, or they're done within the context of a semester at university. The typical academic institution structures, lack of resources, all of these things prohibit us from doing these big sample size studies in those contexts. But there are situations where they have to be done for pedagogical reasons. And it makes no sense to waste that information because it does become, fuel for future evidence synthesis as well. But what we need to be cautious of is, and this is what happens in the hype cycle on social media as well, is the authors try to sort of be cautious and not draw nuanced conclusions. But the reality is they probably just shouldn't draw any conclusions from the data. They should probably just say, hey, we did this thing, we collected some data, we used some rigorous methods, we just couldn't get that many people. Here's the data, here's the open data, go for it. So what Franco's proposing is that when he gets those over his desk, instead of just desk rejecting them like he does now, which just kicks the can down the road and it ends up in shit journal B down there who have got lower standards, he says, look, we can publish this, but the new publication type is going to be, this is a open data set, a detailed description of what you've done, and this is specifically published to contribute to future evidence synthesis. You don't make any strong conclusions from it. In fact, you don't make any conclusions from it. So I think that could be a really useful shift in the way we report and publish research that works with the current constraints that we have. But I think, like I said before, one of the simplest ways to try and shift towards the types of research that we need to do if we say we want to detect differences between interventions in trained populations, then we have to concede that the kind of research we're doing right now doesn't answer those questions for us. Like it just doesn't. We can try and pretend it does, and we can do these small sample meta-analyses and things like that. But unless we're, using other tricks and tips and things like that to get strong conclusions out, like, very strong priors and a Bayesian meta-analyses, and, even in that sense, like, what are we going to base them on? Well, probably like the large data sets that I've talked about and used to develop these black pill theories, which will then just give people the answers they don't want. But shifting towards thinking about studies in the context of, okay, fairly well corroborated theories, at least I think, predict that we get these small effects. Why don't we, if we've got research constraints, try to plan our studies to test for equivalence instead? And try and identify within a region of meaningfulness that we consider important whether or not these are statistically equivalent to one another, or they fall into a little high probability if you're Bayesian within the kind of region of practical equivalence. Or we can combine that. We probably still need to combine that with multi-lab collaborations, because like we've shown, even in trained populations, you still need like 300 people to be able to detect, maybe a bit less, because like I said, we set our error rates they were not typical for the field. So we set our type 1 error rate at 1% rather than a typical 5%, and we had a 95% power rather than a typical 80% power. But even then, you're still looking at 100 plus participants at least to be able to detect equivalence for the types of effects that we're looking at in these populations. So multi-lab collaborations are going to be essential. Or collaborating with industry partners, like so many people in the sport and exercise science kind of world now, particularly in academic institutions. We're all. I know we were encouraged to collaborate with industry, because one, it looks good for the university, but two, it also means you can actually, if you get the collaborations right, do better research. Depending upon the context in which you do it, you can end up doing research that both ends up more internally valid and rigorous, but also ticks that kind of external validity box because you're working out in a real life context. The lab is real. It's not a simulation, but you know what I mean.
Well, the key,
everything's a
physical key. It's real.
I have one too, but I do wonder if anything is real. No, that makes a ton of sense, James, and I hope I didn't cut you off by jumping off on your joke, but multi-site data collection, strong priors, clear priors, And just to emphasize, I think that sort of answers your question, Trexler, is should we? It's not about us. It's about the consumer, right? And in my mind, or the community we're trying to serve. Like, it's not relevant if you can take someone who's in peak physical human condition and get them from a 10 flat, 100-meter time to a 9.9. But we know that's relevant because the stakes dictate it in the sport. Is it difficult to decide exactly what was the principal causatory factor that got someone from a 10 to a 9.9? Absolutely. But if we want to use sports science to inform high-performance sport, and I have relatively strong beliefs that we are already seeing that and is making a difference when we look at some of just which teams in what cases who have leveraged sports science have gotten better without necessarily having a huge change in the cast of characters who are the athletes. I could think of British cycling, for example. I can think of some of the things that are going on in powerlifting with velocity-based training, nutritionists, and RIR and RPE use, and some people moving from what you would think is, okay, like, you're a bronze medalist at Worlds, and now you're a gold medalist. Like, these are the types of anecdotes. It stretches the incredulity of saying there shouldn't be any gains left for you if we were to make you be a demographic characteristic, but as an individual, something's going on there, and how do we do it? That's a fundamentally different set of questions to ask than what's good public health policy related to resistance training. So, not to answer the question for you, James, but my perspective is we really shouldn't be focusing on things like 2 RIR versus 0 RIR, lengthened partials versus full range of motion, high protein versus moderate protein, moderate volume versus high volume, when we're talking about, hey, health. So if you're a sports scientist, I do think that is actually quite different than being an exercise scientist, or at least it should be seen that way as we move forward and try to spend our time in a useful way and not commit unintentional fraud, waste, and abuse. That's at least my opinion. I don't know if you agree, James.
Yeah, I think as well, another thing which I've spoke about in the past is that, and this to some extent ties back in with the industry links, is nowadays so many within a sporting context, so many teams and athletes are collecting so much data, performance-related data, other tests and characteristics, elements of their training protocols and things like that. I think there's a revolution that could be had, and there are a few people in the field who are talking about this, are experts enough to understand and apply it, but there's a revolution to be had in causal inference in kind of longitudinal observational data that I think could be tapped into as well. So someone like Matthew Tanan is already doing some really cool stuff in basketball and other areas, applying kind of approaches from the causal inference world to draw unbiased causal inferences from non-randomized observational data longitudinally. It's something that I'm exploring more and more now, working with Kisa, because we've got 50,000 members, we've got 15 years worth of data, we've got so much clinical outcome data, and we've got all of their training information and medical histories and things like that. But it's not a randomized trial, but we want to be able to understand and draw out some causal estimates of things in the context of that data. I think even that can be something where appropriate use, and this is where I say it with real caution, because with the greatest respect for people in the field, the average sports scientist barely understands what a p-value is or how a t statistic is calculated. Getting them to do complex causal analysis in complex systems can be is maybe a bit of a stretch, but collaborating with experts in those areas might be key.
Yeah, I totally agree. And you don't have to be a statistician to make a meaningful impact. I think the typical training that a sport or exercise scientist gets is one where they become very good at creating a controlled laboratory environment, doing recruitment, doing high quality, high reliability testing, reducing measurement error, and teaching others how to carry that out and getting a group around that and doing good lab work. And that's a tremendously valuable set of skills and environment to create. And if we're not saying, oh, and by the way, you're trash because you don't understand Bayesian statistics or even how to calculate an F statistic or a T statistic or whatever, because, hey, clearly I'm one of those people and who do I collaborate with? you guys, And of course, I'm trying to upskill those things, understand them conceptually. But if we have 100 different labs who are all able to use those skills in a coordinated fashion, now we've actually got something. So I think I don't think you're setting too high of a bar. I think we just need to play to our strengths and then leverage the potential resources we have across the field and in an interdisciplinary manner. I think you're a great example of someone who is going, hey, we may not have the answers strictly within the confines of sports science, but we do have them in adjacent fields. So I think that's actually a relatively hopeful message.
Yeah, and to touch on that, like other fields like psychology, maybe 10 years ahead of us in terms of methods reforms and things like that, having gone through, well, actually probably what was their kind of like second replication crisis, because folks like Paul Mill, who I mentioned earlier, were talking about this stuff in like the 60s and 70s and no one listened.
Well, hey, they replicated the replication crisis. Good for them.
There we go. I just completely lost track of what I was going to say. Oh, I know what I was going to say now. Yeah, like things like the Psych Science Accelerator are a really good platform, and I know that there are people like Franco and Joe Warren at TU Dublin who are talking about how do we develop platforms like that to facilitate these kinds of large-scale collaborations as well. It's a bit difficult in sport, like to get the collaboration between teams, because no one wants to. Everyone thinks there's trade secrets in their data. Like most of them don't even understand how to use their data, let alone that there's trade secrets in there. But yeah, I think certainly those kinds of collaborations. Let me go back to your question though quickly, Trex. Like, do I think that it's a waste of time? I can't really answer that. Like for me, like it's. Like I'm growing less and less interested in those specific questions. And now given my shift into stepping outside of academia and working in particular industry context now, which is I'm leaning more back into the kind of medical space of the work that I'm doing. I'm like, it would feel like a waste of my time to work on it now. But this is what I've always said. Like, I've always been a really strong proponent from a researcher's perspective to pursue the things that they're interested and passionate about, because I think those are the key things that you need in the first place to want to do better. Like, I go back to like what I said like earlier on, which was part of the reason I got interested in understanding philosophy of science or upskilling myself statistically, or in terms of methodologies or specific methods and study designs and all of these kinds of things, was because I was working on a substantive problem at the time and I wanted to know how to do it better. And so I think you need that passion. You need to care about the questions. Whether that's because you're just interested for whatever reason, and no one knows why, or you've got a particular audience, or people you work with. I always used to say the reason I got into lifting was because I watched Dragon Ball Z when I was a teenager. Like, and it's completely true. Like. So whatever drives you, that if you don't think it's a waste, then you're not wasting others' time. Then, yeah, go for it. But do it properly.
I don't have a choice when people look at
the only lifter that's never seen a single moment of Dragon Ball Z. Like I couldn't fathom what it's possibly about, but it seems like there's very muscular characters involved.
It's not just the muscularity; it's also the ethos of I have to train to be better. It's embedded in it, and it's one of the
training.
Yeah, it's one of the they go to different gravity worlds. And the funny thing is I am a pre-Dragon Ball Z anime enjoyer, and then I took away from it. But it is something that's a little more embedded in anime culture. And that's why there's so many lifters who love anime, because there is the idea of strength not being a fixed quality, which it often is in most, I would argue, like Western stories. Like, oh, you got Samson's is strong. God did that, but in a lot of anime, it is someone.
Well, you don't see Superman training a lot.
No.
That's kind of is.
The shonen anime trope of like, they train, they get stronger, there's a big evil, they can't beat it, they have to train more, and then they beat it, and then the next one comes, and this continual kind of progression thing. Wait, so Helms, you're a little bit older, so were you like let me guess.
Quite a bit older, if I may.
Fist of the North Star kind of guy?
Dude, I watched Akira, and that was... So probably the first crossover anime film that started the whole genre of love on the West, and then there was a few others, like the first Vampire Hunter D and the first Princess Mononoke. Yeah. But then it was like 20 years of nothing, and then I come back and I'm like, I can't really get with this. It's like, for me, it's like the 80s and early 90s.
Yeah.
But not to get off topic, but I think that's a fantastic answer. And yeah, I often reflect on my own life. I think the best way to describe my interest in lifting is that it's a special interest that I try not too often for it to become hyperfixation. It's just who I am. It's the only way I can relate to the world. And unfortunately, I'm not alone. But that makes a ton of sense. I think it is not necessarily our duty as scientists to always answer the question of, is it worth it? The question is it worth it for someone? And then that needs to obviously fit with the people who study it, because if we don't actually have a genuine interest or passion in it, then there's very little incentive to do it right. So yeah, I like the way you answered that. Trex, I'm sensitive that we've gone all over the map here. I feel like we've got a nice bow tied on this, but I do want to open it up. James, are there things that you think we haven't adequately covered in this? Because I think you've done a really good job of identifying the problem, helping people understand the pros and the cons of the status quo, and what actually needs to be done to move forward, and provided a nice measured, for a black pill gentleman, a nice measured view of, we have some issues, and a lot of what we're doing is not doing what we think it's doing, but it's doing something, and we can do better. Would you say that's a decent summary?
I think that's a pretty decent summary, yeah. I didn't come off too badly then.
No, you did fine. You did fine. It's good to be critical, especially if it leads towards something.
And I just want to say that I'm not there yet, but I'm open to being somewhere in the future where we can bury the hatchet, and I will no longer dislike you for the black pilling that you're responsible for. But on a serious note, I am so appreciative that you have joined us for this really informative conversation, and I want to let the audience know just how legit James Steele is, if you're not convinced yet. I believe that there are exactly two people that publish or have published in exercise science where if they reviewed my stats and just told me, Eric, you're wrong, I simply wouldn't question it. Other people will catch me making mistakes. I'm sure of it. But there are exactly two people where I wouldn't even fathom or consider the idea that they are mistaken. I would just say, okay, you got me. It's James Steele and Andrew Vygotsky. So I just want to take a moment to praise James Steele and put him up on the pedestal where he belongs, because I think there are many tiers of like statistical and methodological bona fides in the exercise science world. And I don't think people can really tell beyond a certain level who really knows their stuff here. Allow me to be abundantly clear. James Steele and Andrew Vygotsky are on a fundamentally different level. I haven't heard from Andrew in a while. I think he simply outgrew exercise as a concept, which honestly is fitting.
He's
I
still
don't
doing
know
his PhD.
He's
but it's more.
Actually, I think he might have defended. I literally messaged him this morning.
Did you really?
Yeah. I think he was either defending last. Well, he's either about to defend or he's just defended.
But he's gotten more into like. I know for a minute he was doing like real biomechanics, and then maybe something related to pain. Is that right?
He's doing a lot of work in kind of pain psychophysics and pain research at the moment. Yeah. He's shifted away from exercise, which I think is a good move for him. And he's doing.
I don't think we deserved him. I gotta be honest.
He still responds to my emails, to his credit, so he'll still. Yeah, but he still helps out the old homies.
I really don't think we deserved him, and I genuinely believe he outgrew the field. Definitely. Good for him. But no, I just really appreciate you, and I want to make sure people understand the legitimate stratification of statistical knowledge within our field, and just give you the props you deserve.
Wow, I'd always put Andrew just that bit above me, definitely.
He's scary. He knows too much.
Yeah. I always felt good when I got to the point where I stopped like WhatsApping Andrew to just check things with him.
I still remember one of my like really proud moments was kind of chatting with Andrew and me identifying something that I thought was a good question. And I was totally braced for him to say, "You fool, here's the answer." And he said, "No, you've identified a good question." And I was like, "Oh my God, I can't believe this happened." And I don't think I've talked to him since, because I was like, I don't want to ruin this.
I will. I'll give you a very quick sneak peek. Part of the reason I messaged Andrew this morning is because Israel Halperin, Andrew, and I have been chatting about some RIR related ideas, but they do tie very nicely into what we've been discussing today, which is we've been thinking we're trying to think very carefully through some theories regarding kind of data generating processes for the RIR data we see in different set studies, and then we're going to do some simulation work and try and think of some study designs that might test some different, basically test whether or not kind of reps and reserve type models lead to kind of quote unquote self-fulfilling prophecies regarding the rep numbers that people get.
That is something I've always been curious about, because it is a built-in flaw of the design where if you call out a certain RIR, where are you? Which is why I'm very interested in the velocity-based stuff, right?
That's how you get Andrew back into anything exercise related, because if it's like actually a genuinely difficult puzzle to try and solve, then he gets interested.
And that is the times I've actually emailed him too.
Yeah.
So I'll keep that in mind. But there is definitely something to be said for the stratification, because you know the level you're at when you can't distinguish between the level higher than you. So I'm at a point where I'm like, oh, Trexler, James, and Vygotsky can actually tell the difference between one another. I can't. Or they're all just having a humility battle, which is possible. But I just want to echo what Trex said. I really do appreciate not only the time that you've given us on the podcast, but also what you do for the field. And if folks do want to follow more of your work, I know you do have an Instagram account, but that's probably not where you'd send people first off the bat. Is there an X, or do you want to give them your ResearchGate? Where do you want people to follow you at?
Research-related stuff, probably ResearchGate is the best. I actually shut down my X recently. I went with the other academics onto Blue Sky, but I'm still trying to figure that out. But yeah, still some of the usual kind of slightly shitposty research-related stuff on Blue Sky from me. I'm trying LinkedIn now. I work in the corporate world in industry, and I still can't quite get the idea of that. People don't seem to take to shitposting quite well on LinkedIn as they did on X, Twitter. X.
Well, there's always shitposting for Instagram.
ResearchGate.
In LinkedIn, the only post you make are you say, "I'm so pleased to gratefully accept this promotion I got today," or it's always got to be a promotion, leaving a job, or starting a new one.
Exactly, yeah. And Instagram, if you want pictures of Kiki and random videos of me playing Beat Saber.
Perfect. And you do occasionally share some research on there as well if you get tagged. So awesome. Well, thank you for that. We'll have all of that in the show notes. I just want to thank everyone for joining us for this pre-recorded episode of Iron Culture. We will be back with live ones soon. And thank you for tuning in. And once again, please do leave some ratings and reviews. Support us at the Mass Research Review, and come meet us in person live. Just coming up in April on the 12th and 13th at the annual SNA conference. And we will see you next week on Iron Culture.